In this part of the series, you are going to look at velocity time graph. Now, there are some basic things you are supposed to know. We already know that velocity is distance per unit time. So, velocity time graph, how to draw the velocity time graph. So, know that your velocity is here, your time is here. Now, when we say constant velocity, it simply means that constant speed. So, it means you have your diagram looking like this. So this is a representation of constant speed or constant velocity where a straight line is parallel to the x-axis. Now, so constant speed. So throughout the questions, anytime you see constant speed, this is how our diagram is going to look like. The line is going to be parallel to the x-axis. So there's another term you would hear, uniform acceleration. Velocity here and time here. Uniform acceleration. Acceleration means what? Increase in speed. Should it be the last? Okay, we'll look at more. So anytime you have a decrease in speed, so you have your velocity here, your time here. This is how the diagram is going to look like. So this is also called uniform deceleration or retardation. So it moves this way and then goes that way. Your velocity is here, your time is here. Because it looks like initially the speed was just increasing regularly, then just switched. So this is non-uniform acceleration. So non-uniform deceleration would be something like this. So it comes this way and then goes that way. This might not be necessary when solving calculation questions, but might be necessary for explanation. So let's look at this question. A car moves with a constant velocity of 10 meters per second for 5 seconds. What is the acceleration of the car? Draw the velocity time graph for this motion. So the first demand is to find the acceleration. So in the previous series, I explained to you acceleration equals velocity over time. So your velocity in this question is 10 meters per second, 10 meters per second over your time, 5 seconds. So cancelling through, you are going to have 2 meters per second squared. Now take note that there is also what we call distance time graph. This we are dealing with is velocity time graph. So a distance time graph, you actually see distance here and time here. And that one to just be dealing with distance traveled to time. It follows the same approach. So for the sake of this lesson, so you have your velocity here, you have your time here. So this place is 0. That's for the spot. Now a car moves with a constant velocity. Now remember our diagrams. Constant velocity goes this way for 5 seconds. So constant velocity of 10 meters per second. So you can write 10 meters per second here. Then just make some short dashes. So 5 seconds. Now an extra question. You can be asked to find the distance traveled. Now anytime you're asked to find the distance traveled, you can just find the area. Once you find the area, you know the distance traveled. So with this, you have a rectangle here. This is a rectangle. So finding the area of this rectangle, the distance from this spot to this spot is 10. And this side to this side is 5. So you're going to have what? 50 meters. 50 meters. How do I know? So velocity equals distance over time. Now, when you make distance the subject, you're going to have velocity times time. So your velocity here is 10 times your 5. That's 50. So let's move to the next question. A car starts from rest and accelerates uniformly at 2 meters per second squared for 5 seconds. Draw the velocity time graph for this motion, or the total distance traveled by the car. Now, you can pause the video and then try this question. The car starts from rest. So information given is 2 meters per second squared. Then your time is 5 seconds. So we move straight into action. Draw our diagram. You have velocity here, you have time here. Now, we don't know velocity. What we know is acceleration and then time. And from our previous series, we can find the velocity. So, acceleration. I've always said in my series that sometimes you are given a question, you can't find exactly or directly what you asked. Sometimes you have to use the previous knowledge you know. That's why I say science is cumulative. So, velocity on time. Acceleration is 2, so 2 equals velocity over time is 5 seconds. So we are going to have what, 10 meters per second. So we know our velocity to be 10 meters per second. So because we are drawing a velocity time graph, that's why you're supposed to know the velocity. So 10 meters per second. Alright. So we know our time to be 5 seconds. The car starts from rest and accelerates uniformly. Remember our diagrams. Start from rest. This is your 0 mark. So starting from rest and accelerating uniformly, this is how you expect the diagram to be. So I can start from rest and accelerate uniformly at 2 meters per second for 5 seconds. So this acceleration lasted for 5 seconds. So draw our short dashes and indicate our 5 down here. Knowing that our velocity was 10 from the answer we had here. So we know that the velocity over here is 10. The next question is, what is the total distance traveled by the car? Now, the diagram that represents the question looks like a right angle triangle. And I said that to find the total distance traveled, find the area of the figure. Now, this figure here is a right angle triangle. And area of right angle triangle equals half times the base times the height. So half multiplied by the base. The base is 5 times the height. 10. 2 here 1, 2 here 5. So total distance traveled is 5 times 5, 25. Unit for distance is what? Meters. A car accelerates uniformly from 0 meters per second to 20 meters per second in 4 seconds. So let me just highlight the most important information. If it moves at a constant velocity for 6 seconds and decelerates to rest in 5 seconds, draw a velocity time graph, all acceleration and total distance traveled by the car. There's so much information to imbibe here. So we are asked to first draw, but let's take it step by step. So the car moves, accelerates uniformly from rest. So remember our diagram. This is the rest, 0. So we indicate our 20 on the velocity side. So 20 meters per second for 4 seconds. 4 seconds. It then moves with a constant velocity for 6 seconds. I have to extend this. So we extend this. So for another 6 seconds. So if for another 6 seconds, it means that this time is going to be added. So a total of 10 seconds. And decelerates to rest in 5 seconds. So decelerates to rest in 5 seconds. Now a total of 15. So we are asked to draw. We are done drawing. What's the acceleration? Acceleration. Where did acceleration take place? Acceleration took place at this point. That's where acceleration took place. This is the point where acceleration takes place. And this is the point where deceleration takes place. So if acceleration took place here, pick up the information from this side and then find it. So acceleration equals velocity over time. Now, in this area, our velocity was what? We actually have two velocities. We have initial velocity and final velocity. Initial velocity is 0, final velocity is 20. So final velocity minus initial velocity over time. So our final velocity was 20 minus initial 0 over time. Time is 4. So 20 minus 0 is 20. 20 divided by 4 is given as what? 5 meters per second squared, because acceleration. The next thing we are supposed to find is the total distance traveled. Now, in order to find the total distance traveled, as I mentioned, find the area of each of the figures. So this side, we have right angle triangle. So half base times height. Let's call this place A. Let's call this B. Let's call this C. So for our A, half times base times height, half times our base is 4 times our height is what? 20. So 2 here 1, 2 here 10. 10 times 4 is 40. So we have 40 meters. That's for our A. Then for our B, this is a rectangle. So we are going to have length times breadth. So our length is 20. Then our breadth or width is 6. 20 times 6 is 120. 120 meters. That's for our B. Then for our C, we have a triangle as well. So half times the base. Base is 5 times the height 20. 2 here 1, 2 here 10. 10 times 5 is 50. So over here we have our 50 meters. So we have 40, we have 120, and we have 50. So we are going to add them. 40 plus 50 is 90. 90 plus 120 is 210. A plus B plus C is all 210 meters. That's our total distance traveled.